Yesterday we saw that organic bases and factors affecting the strength of organic bases. So there are 5 factors which affect the strength of base. So first factor is availability of lone pair of electron on base. Okay, if there is a more electron pair available on base, the base strength increases. If the availability of lone pair of electron decreases, base strength also decreases. Second factor is the electronegativity of B or electronegativity group present in the base. So if the electronegativity group present B increases, the strength of base decreases because it decreases the ability of lone pair of electrons. And on the other hand, if the electronegative group in the base decreases, the availability of electron pair increases and hence the strength of base also increases. Okay, so third factor is structural effect in base. So there are mainly 2 types of structural effects. So one is electron donating and other is electron withdrawing effects. So in withdrawing effect, minus I and minus R effects, and in donating effect plus I and plus R effects. Okay, so if base contains group which donates the electron pair, or which there is an increase in availability of electron pair, okay, and which increases the strength of base. On the other hand, if there is withdrawing effect, electron withdrawing effect is present in the base, then the ability of electron pair decreases and the strength of base also decreases. So fourth factor is the stability of conjugate acids. We know that after the protonation of base, there is a formation of conjugate acid, which electron deficient base. Okay, if there are electron donating group on the base, then this conjugate acid gets stabilized. That is, if the electron donating group is present on the base, then the stability of conjugate increases and hence the strength of base increases. So last factor is the nature of the solvent. Okay, we know that the nature of the solvent is also plays more important role in the base to determine the base strength by solvation factor. So if the conjugate acid form is charged species, then there is a form polar solvent stabilizes that conjugate acids. Okay, if the if the attacking species or attacking base is charged species, then there is formation of neutral conjugate acid. Then in that case there is non-polar solvent which increases strength of base. Okay, if attacking or base having neutral or it having a lone pair of electron, then after the protonation there is formation of conjugate acid. Then this conjugate acid gets stabilized by the solvation by polar solvent. Okay, these factors are studied in last lecture. So next factor is there are types of bases. There are 3 types of bases. One is aliphatic, second is aromatic, and heterocyclic bases. Okay, these are the organic bases. So let's see one by one. So first let's take aliphatic acids. Aliphatic bases. Aliphatic. To understand the aliphatic base, let's take a series of ammonia derivatives. NH3, NH2R, NHR2, NR3. So ammonia, primary amine, secondary amine, and tertiary amine. Let's take these series. Okay, we know that this nitrogen having a lone pair of electrons, so it can be available for the donation. So in this series, we know that So as we go from ammonia to tertiary amine, the plus I effect increases, and as we know that the plus I effect increases the base strength. So here is 1 plus I effect, 2 plus I effect, and 3 plus I effect. In this case there is a more plus I effect. So according to theory, this should be a stronger base because it contains a more plus I effect and it contains more donating groups. So ability of electron pair in this base is more. So according to theory, this is a stronger base and this is a weaker base because it does not contain any plus I effect. So but actually in practice this is less basic than secondary amine. Okay, the actual trend is ammonia is weaker base than primary amine. Primary amine is weaker base than tertiary amine, and tertiary amine is weaker base than secondary amine. Okay, in this series the secondary amine is more stronger base. Okay, so other than plus I effect or donating effect, there should be something other effect that decides this is that changes the trends and making the secondary amine more stronger base. Okay, let's see what that effect will decide makes this as a more stronger base. We know that after the protonation of secondary amine, there is formation of conjugate acid. Okay, we expand the structure to better understand. Okay, this forms a conjugate acid. Conjugate acid, and this is a secondary amine. Okay, let's take another derivative. Okay, there is formation of conjugate acid of tertiary amine. Okay, these are the conjugate acids of secondary amine and tertiary amine. Why this is called secondary amine? Because it nitrogen attached to 2 other carbons, so this is secondary amine. In this case, the nitrogen attached to 3 other carbons, so this is a tertiary amine. After the formation of conjugate acid, we know if the solvent is water, then this conjugate acid gets solvated by the water molecule by hydrogen bonding. So in this case, there are 2 hydrogen atoms. So these 2 hydrogen atoms forms a 2 hydrogen bonding with water molecule, 2 water molecules. So this one is this one. Okay. So in this case, in case of secondary amine, conjugate acid forms a 2 hydrogen bonding with the 2 water molecules. Okay. So in case of tertiary amines, after the solvation, one water molecule forms only 1 hydrogen bonding. Okay. So conjugate acid of tertiary amines forms only 1 hydrogen bonding. In this case, there is a 2 hydrogen bonding. So this is a hydrogen bonding, H bond. H bond. This is also H bond. Hydrogen bonding. So in this case, there is 2 hydrogen bonding. In this case, there is only 1 hydrogen bonding. So more is the solution factor. More is the solution. More is the stability. Okay. In this case, 2 hydrogen bonding. So this conjugate acid is more stable than this one. So after we know that the stability of conjugate acid increases, the base strength increases. So this conjugate acid is more stable than this one. That's why the secondary amine is more stronger base. Okay. So even though it contains less plus I effect, it is a stronger base because of solvation factor. Once again I repeat. So even though it contains less plus I effect, it is a more stronger acid because of more solvation. Okay, we know that the plus I effect increases, the basicity increases. So plus I effect increases, basicity increases. Okay, logically, if minus I effect increases, then basicity decreases, or minus I effect increases, basicity decreases. Okay, let's take an example. Well known example. If nitrogen CF3 I expand this group. Okay, this is also CF3. I expanded this one to elaborate minus I effect. Okay, so there are total 9 fluorine atoms. We know that fluorine atom having a minus I effect. So minus I effect, minus I effect, minus I effect. So fluorine exerts minus I effect. So here is 9 fluorine atoms. So here is more stronger minus I effect, making which decreases the lone pair of electron pair. Even though here is a electron pair, but it is not available for the donation because of 9 fluorine atoms which having a strong minus I effect. So this compound is even though it contains lone pair of electron, it is a neutral compound. So this compound is neutral one. So what is the reason this compound is neutral? Because lone pair available, lone pair here is lone pair present on nitrogen is not available for the donation because it's because of 9 fluorine atom which exerts the strong minus I effect on nitrogen atom. So it does not give its lone pair to the H plus ion. So this is a neutral compound. Okay. Next point, the group which having minus R effect also decreases the basicity. Okay, group which having minus R effect decreases basicity. Okay, let's take example. Amides are extremely weaker base. Okay, let's see why amides are weaker base. Okay, let's take example any general amides. Okay, so we know that the nitrogen having a lone pair of electron, but it is not available for donation because of minus I effect of carbonyl group, group. Okay, so this carbonyl group exerts minus I as well as minus R effect. Okay, so this lone pair is in resonance with the oxygen, so carbon. So there is a resonance structure. Okay, so this lone pair is busy in the resonance, so that's why it is not available for the donation. So this is a weaker base. Okay, if there are two carbonyl group attached to nitrogen, okay, which exerts strong minus R effect, and making this compound acidic in nature. For example, thiamine. Okay, here is a nitrogen which having a lone pair of electron, but it is in conjugation with the carbonyl group. So there are two carbon group which pulls this electron by minus R effect. So this is not available for the donation. So it is in conjugation with the carbon group. So there is a resonance structure. This is getting positive charge. Okay, after the so here is a loss of H plus. If there is any base, then this abstract the proton. Okay, there is a formation So it loses H plus ion, so it is acidic in nature. So thalliamide, even though it contains nitrogen having a lone pair of electrons, it is acidic in nature because of the 2 minus R effect. As we know that the minus R effect increases, base strength decreases. So here are 2 minus R effects which decreases the basicity of this and making it more acidic. Okay, let's stop here.